Hello, everyone. Thank you for joining our webinar. Speaking today is Project Manager Alex Sutton, along with Raphael Skutnicki, Technical and Hardware Lead from Averna. We're also pleased to welcome special guest Graham Green, Chief Production Solutions Leader with NI. Before we begin, I would like to inform everyone that you'll be automatically muted, but we'll be answering questions following the presentation. And now let's begin.
Hey everybody, as Amy said, I'm Alex. I'm really excited to talk to you guys today. I've been with Averna for just over 4 years now and have had a chance to help develop and launch a bunch of really cool systems in a variety of industries. Having worked so closely with our customers within different circumstances, I'm glad to share some do's and don'ts when it comes to test execution. I'm joined here by Raphael, whom I've worked with on several projects, and of course, Graham from NI. Raphael, can you start by introducing yourself?
Of course, thanks Alex. Hi everyone. I'm also really excited to be here. Like Alex said, we've worked on quite a few projects together over the years, and we kept seeing patterns in the way our clients were directly affected by standardizing tests throughout their organizations. I wanted to take the opportunity to hopefully help guide you all towards more efficient ways to test using our experience, and I'm looking forward to hearing from NI as well. Graham?
Thanks. Yes. So I'm Graham, working here at NI. We're a market leader in test instrumentation and test data solutions. The interesting thing about working in a tools company is that we work with OEMs and integration partners and manufacturers and product designers all across the world and across multiple industries. And so we're getting a really broad sense of what's happening in industry right now and the challenges faced by test engineers, along with the best practices they use. So I'm looking to share some of those today, along with my friends here from Averna.
Great, thanks guys. So quickly, our goal today is to share our best practice with you on how we can implement test standardization to see a return on your equipment investment very quickly. We're going to start by defining standardization and where it is most helpful. We will look at equipment reuse, including common core test stations and how to invest in them wisely. We'll then hear from Graham on hardware and software, and we'll talk about how standardization will help eliminate the very real risk of component shortages and remove communication inefficiencies.
After that, we'll open the floor to any questions you may have. So let's get started by clarifying what we mean by standardization, because it can be interpreted in different ways. When we say standardizing tests, we are talking about a couple of aspects here. We're referring to the reuse of the same hardware and working with the same software interface whenever possible. We're also referring to roles and departments. Is the R&D team leveraging the same equipment as the support and repair team, for example? Is the manufacturing team in Mexico able to understand the tools being used by the development team in the Netherlands? Standardizing across the board puts everyone on the same page, speaking the same language. Speaking Spanish versus Dutch is one hurdle for sure, but speaking R&D versus manufacturing, just as much can get lost in translation. Simply because each team has their own set of priorities. For example, R&D needs to develop a product to satisfy the customer's needs, whereas manufacturing needs to find the most efficient way to build it correctly. Each is extremely challenging, but for completely different reasons. So it only makes sense for them to focus on different things.
That's exactly right. And they have different priorities as well, right? We've seen it all the time working on different kinds of projects. When everyone's on tight deadlines, cost pressures, and component shortages, things get a little crazy. Even more so when you acknowledge that typically these teams work in silos and only focus on their part of the bigger picture.
Exactly. It becomes difficult to achieve anything efficiently when everyone involved has a different goal and is speaking different languages. So now we wanted to take the opportunity to share some of the best standardization strategies we've come across to avoid these, let's say, inefficiencies. But really, there are frustrations. Hopefully, you will be able to apply them moving forward.
Yeah, Graham, you've been working in this industry a long time. Maybe share NI's view on standardization.
Yeah, I mean, what you said is totally correct around the efficiencies. But I think the driving force behind those efficiencies is that, yeah, for the last 15 years working in test engineering, I've never seen before this a perfect storm of challenges coming and hitting our departments. The products we're testing are getting way more complex. What used to be maybe a mechanical or electromechanical device often has embedded intelligence, communication, radios. There's a lot more to test. And it's unlikely for many people listening today that their team is growing at the same rate that their test coverage requirements are. And so we have to do more with less. Now, the promise of how to do this, a lot of that, the excitement is around digital transformation. We hear this term meaning a lot of different things in industry. But fundamentally, digital transformation for test has to be built upon a really solid strategy of automation and standardization. You know, if you're the slide you see in front of you shows that generally the trajectory that we see companies going on starts with automation. They're looking at their test coverage and abstracting development towards more commercial off-the-shelf or efficient tools. Then they take that and they're looking to either standardize horizontally in a single product line, also across multiple product lines, but within a single function, or standardize vertically. So taking a single product, but standardizing or reusing IP across multiple functions. If you can do these two effectively, you're not only able to, you get a standard set of technology across your company, including the systems and the data, but also you start as a company building this muscle memory, this organizational structure where people are thinking holistically and making bigger decisions. Until you have the people and the processes and governance and the technology in place across your company in this sort of standardized fashion, it's very hard to be able to then use that to be able to make decisions upon that data and all the wonders of analytics and digitalization that we want to step towards. And so, as I think to summarize, standardization is very much the gateway to this digital transformation. But ensuring that you've got a strong foundation in standardized tests is the top priority for many of the organizations we see today. That's where people are on this road, a lot of companies, but it's not easy to do. And so that's what we'll be talking about on this webinar. And so I'll pass back to my friends at Averna because they're pioneering a lot of the best practices in how to actually effectively deploy this at the companies.
Great perspective, Graham. I appreciate it. And so let's get down into it, right? How does investing in test standardization pay off? How can you guys do it intelligently? In the introduction, Raphael mentioned a few points that we want to elaborate on. We're going to start with equipment standardization. So there are a lot of strategies that can be taken to standardize hardware within a company, and it's important to understand the ultimate end goal. We'll give you a few examples, right? Sometimes you have to start tearing down some of those walls in between your silos too. A few years ago, for instance, I worked with a customer who's all about standardizing tests. We ended up designing an incredible station for them that included everything. I really do mean everything. They were then able to take that exact design and use it anywhere on their manufacturing floor, regardless of product type, with no modifications required. It was great, but they were still using these standardized testers, you know, company-wide, right? But this company has a huge budget, and their engineering fees they wanted to pay one time for NRE, and that would be it. From then on, everyone started working with identical equipment. In this case, cost was not a factor, but simplicity was.
Just quickly, in case some people would not know, so NRE, non-recurring engineering fees, is the amount that is charged for the initial design of a system. Basically considers how much of the engineer's time it will take to build something from scratch, and that cost can get, you know, up there.
Exactly. You know, the more you put into NRE up front, you know, more complexity maybe in your standardization, your upfront cost can be more expensive. But in general, by approaching the test this way, the customer ended up with a true all-in-one solution that they could pick up and use anywhere within the company. That said, they also ended up with a pretty expensive repeat station that wouldn't necessarily leverage all of the equipment built into it. Rafa, you had a pretty opposite example, am I right?
I did, yes. So my customer's priority was speed. They needed a test platform to test multiple PCBs, and they wanted it to be done quickly. So we worked on a design that wasn't exactly flexible, but could be tweaked with slight differences to accommodate different products. They bought several upfront, so all products could be tested in parallel. So this is another good strategy, but not necessarily one with cost in mind. The priority was speed, and they had the upfront capital to do it. In the long term, this demand for these products could easily change or even disappear entirely, and they are left with extra equipment that won't get used.
That's exactly right. So if budget is a priority, then you need to see a quick return on investment. You need to maximize equipment reuse as much as possible to avoid investing in new or unnecessary hardware within your core system. It is hugely impactful, particularly now when equipment is not readily available. By reusing equipment, you not only save money on hardware costs, but you also move faster by not waiting on suppliers or shipping companies. You have what you need, and you just tailor it to the proper application. The easiest way to maximize reuse is through developing common core test stations. These generic stations can be significant investment up front. They pay off very quickly. Rafael, can you please elaborate on the design aspect a little bit?
Of course. So when considering the design of a common core or generic station, the main and most important question to ask is, how do I maximize instrument usage? Test equipment can get expensive, and it is particularly costly when it is underused, like in the case you described, Alex. You must make sure that the test station can share tasks among different product types, but doesn't have more equipment than necessary. You can do this by building an unchanging station core with the ability to swap unique fixtures in and out to accommodate different products. And by the way, I want to point out quickly that once we delivered the stations to the client I was telling you about earlier, they came back to us and asked for a proposal on designing a common core station instead. So, the savings makes it extremely worthwhile. So when designing a station, one needs to decide if a hardware component belongs in the core or as part of the unit under test or UUT specific fixtures. This trade-off is what will define the success of the design. If there is too much hardware in the core, the price of the test station goes up. But if there isn't enough, it reduces flexibility while increasing the complexity of the fixture. The way we approach a concept like this is by starting with the expensive and highly reusable hardware like spectrums, generators, HiPods, power supplies, PLCs, and automatically design it into the core. Then we look at the lower priced and more specialized items and move those into the fixture side. The in-between items require a little more investigation and analysis, so there isn't one hard rule on how to design this.
That's right. I mean, if you look at the expensive cost of instrumentation, you want the upcycle time of that piece of instrument to be as much as possible. That's how you get a very quick return. And before we move on, I want to highlight that this is just on the hardware side, right? Like the same applies to the software architecture. The test executive will include necessities like test data management for all inbound, outbound information and sequences. Often we will use an off-the-shelf test executive, like Averna launch to save costs and not reinvent the wheel. Test packages for specific products, including UUT APIs and other requirements unique to a product family, are written separately. So that's the general concept of a common core test station. I'm pretty sure we have held a webinar in the past dedicated to the subject. If anyone wants to check that out, our team took some time to go over the design tips to maximize overall efficiency. There's even a design matrix, I believe, included to help you make some of the decisions around instrumentation and other expensive hardware.
Yeah, that's right. Now, with that said, the concept goes a long way into maximizing profitability. Let me give you a recent scenario. So we were working with a company who was phasing out one product while the demand for another was doubling. Initially, their two options would have been or buying dedicated test stations for each product, or buying X number of common core stations and swappable fixtures to accommodate demand. They had decided to go with a common core station. So when the shift in demand came up, they avoided investing 265K into another dedicated test station. Instead, they asked us to build an additional fixture for product B, and they were able to reuse the core from the end-of-life product A. The initial core had cost somewhere between 150 to 100K back in the day, but it had long since paid itself off, so it was a really good choice.
Yeah, and in this case, Averna was involved in it originally, so we already had their designs, and it was easy for us to accommodate. They saved over 10 times what they would have spent on a standalone station. They added 0 new units of floor space, and they had what they needed within a few weeks. The customer I told you about earlier won't have this option. It will be the same cost no matter what.
Right. Truth be told, we believe in the concept of common core platforms for standardization so much that we have developed several designs in-house to accommodate different applications. To date, we have one for AR, VR, MR calibration, one for active alignment, another one for EV power components, and one that we would like to show you quickly for general electronics. Here's a look at Uniline.
With over 20 years in the business, Averna stations are designed to maximize throughput, yield, and ROI. It is time to leverage that experience to reduce development time and accelerate manufacturing for any industry with Uniline. Averna developed their automated universal inline platform for fast and flexible testing with a modular design to meet a huge range of technologies and volume. Uniline maximizes equipment reuse with flexible fixturing to accommodate multiple product types, variations, and flux in demand. Uniline is easily scalable, making it simple to standardize test. This allows you to minimize operator intervention and ramp up so quality goes up and costs go down. Automated testing has never been this easy. Talk to Averna and bring manufacturing to the next level.
Yeah, this is a great solution, and we're really proud of it here at Averna. Thanks, Raphael. This is an important point to bring up because once you look to standardize test equipment, a big chunk of those costs go up front towards that non-recurring engineering we talked about earlier.
That's right. And I've worked on some proposals where this number can seem intimidating, but it only happens once at the beginning of the project. Any repeats of this station won't include this amount.
Exactly. So in order to save costs, we highly suggest investigating customizable test platforms. It will certainly be work to do to tailor the equipment to your application, but a solid portion of that non-recurring engineering would have already been invested while the platform was being developed.
Yep. I think the last thing we should point out regarding generic platforms and how it relates to overall standardization is that this concept is not limited to manufacturing. When we are talking about test standardization, we're looking at the entire product lifecycle. Alex, can you talk about R&D?
Yeah, for sure. I'm tempted to say that within research and development and even new product introduction, it's where standardized equipment pays off the most. And to be honest, that may not be true in all cases. But think about it, the design of any device, whether it's a phone or component for a ventilator or distribution board, it needs to be agile. And the same applies to the design of the station as it is going to be used to test it. A UUT is going to start off a certain way, and through development processes, it will become obvious what works and what doesn't work. From a test perspective, the overall principles are the same, but will need to be altered to accommodate the new design or form factor. Things change through R&D and new NPI. So this means the verifications, validations, and inspections, both for hardware and software, will continue to require the same procedures. And by designing the expensive test equipment into an unchanging core, that investment only needs to be made once. As the UUT changes, it's the most affordable fixture and some new code that you need to think about rather than really building the entire thing from scratch.
That's right. And the exact same thing can be said for support and repair. In fact, I'm tempted to say this is where the equipment pays off the most, but we shouldn't fight in front of everyone. The repair center scenario, I think, is the ideal environment for a generic test station. Typically, a test station will be required for each product that is produced over, let's say, 20 years, but will only be used less than, 10% of the time? Can you imagine having a dedicated test station for every product that has been manufactured that remains supported? We're talking about millions of dollars of test equipment collecting dust because companies are still required to support customers from time to time. It only makes sense to invest in fixtures and 1 or 2 base cores, right? So we'll pass it back to Graham so he can elaborate on the different equipment that is best for standardization according to different scenarios.
Hey, thanks so much, guys. There's been a great discussion around NRE, and I couldn't agree more that trying to balance the total cost of ownership of your test station with the NRE and the hidden costs around that within the lifetime of that test station is the way to start making decisions. I'd agree with Alex's point as well, that as we move from just thinking about hardware, a test station has a lot of software and a lot of infrastructure and then processes that go around it. And I want to expand on that a little bit more. Here's a diagram that we use in NI to look at all of the different components of a test station for functional tests or in manufacturing. You can see we start with the device. This has to come from the end user because you're the expert in your product. Now, above that, you have the infrastructure. This is where here at NI we work most closely with our integration partners, such as at Averna, and it's where that Uniline solution fits in the most. You can see here we have our automation, our fixturing, our sensors, the controllers and rack and safety, etc. Then you have your instrumentation. We'll come on to this again later because that's an important and critical and also somewhat expensive part of the test station from a percentage perspective. But then above that, there's a lot of different software components. Now, from my experience working with different customers, when people think of platforms, they often start with the hardware. They start from the DUT, which is why I explained it in this direction. And they think, well, here's my DUT, and then here's my fixture, and then here's my standard instrumentation. And then we'll write some software. But there's massive savings that can be made in being really purposeful about everything from your test steps to your architectures to your user interface that's going to be used on the floor, not trying to redesign that, through your the health and operations of your system, right up into the data connectivity and into your analytics and operations at the top of this structure. The more purposeful you can be about making a decision for every box you see on this graph before you start building your platform, the more successful you'll be in the long run. And then, of course, I would add to this the things that aren't represented because they're not as physical. I mean, think of how you're going to gather your requirements. How are you going to manage these assets or operate them and sustain them? What does your development process look like? Can you standardize your onboarding process for new engineers or your proficiency or code review process? What about the governance of this test station? How will it evolve over time? If you have an NPI that comes along that has a different set of requirements, whose decision is it whether you're allowed to change that platform, add some more functionality, either in hardware or software? The last thing you want is to do all that NRE cost up front, and you justify the sponsorship of that with your leaders because you expect a long-term saving. And then, before you know it, that platform has branched into 5 different versions, then 10 different versions, and then you're back where you started. You've done the upfront cost, and you don't get any of the savings because you've branched it out too much. That's fundamentally just a governance and process issue. That's nothing to do with the engineering itself. So these things should be considered. Now, let's take a look at implementation of what this looks like. I've got an example from GN Audio. So there's a company based in Denmark, probably most well known to people on this call by one of their sub-brands, which is Jabra, make the headsets that many of us are wearing today. So in this example, you can see the quantity of components, both in mechanical power and safety, instrumentation, and software that was reused from one product to the next. Really, all you're changing is the fixture and the sequence, and then maybe there's a couple of measurement functions that you need to write that are new for the new product if there's expanded test coverage. But in this example, I mean, they had a 2.5 times growth, or 250% in the test coverage requirements from one product to the next. And they had to deploy this globally at 6 different manufacturing locations. And despite that, they can churn out an NPI for a new product in less than 2 weeks, which I think is a huge achievement. And so in this case, where time to market in the competitive consumer electronics world is really king, standardization absolutely paid off for them and will continue to be an area of investment. Now, I just talked about process and software and how important that is. Of course, as I said, the hardware and specifically instrumentation is likely to be one of the largest line items on your bill of materials. So let's have a look at a couple of different technologies that can be used here. The first one is PXI. PXI is an industry leader. I'm sure many of you will be familiar with it. Deployed thousands of systems over the last 20 years, tens of thousands of systems, currently in operation today. Now, PXI lends itself to standardized approaches like this due to the modular nature. If you think of the chassis, it's kind of a fun exploded picture of one on the left. This is physically a limited size, and you can fit a lot of different instrumentation into this relatively small space. One best practice that I would say here is that Raf talked about the flexibility you need as you get increased test coverage beyond that core platform. But what if I need to add one extra instrument? What if I need to just tweak something over time? Well, if you're going down a modular approach and you already have your chassis, that can be as easy as putting in a new module, and maybe there's a little bit of wiring to do and a little bit of software to write, and you're good to go, and you can with your expanded test coverage. If you're going down a non-modular instrumentation approach, maybe with box instruments, they're just physically much larger, and finding space within your test rack for those more bulky instruments can incur you a lot more engineering costs as you try and reconfigure that system. So I will say best practice here is that if you're designing your core platform and you need maybe 6 modules, great, leave those last 2 slots empty. If you need all 8 modules, well, get a big chassis. Spend the extra couple of $100 on an 18-slot chassis to make sure that you have that expandability for the future. Because unless you're very confident that your specifications won't evolve, which I've barely ever seen, having that extra space is really useful. However, we also recognize that for some applications, maybe with a lower test coverage or a higher margin pressure, putting validation grade instrumentation, such as you get with PXI, can be overkill. We've had this feedback for a few years. And so I'm really pleased actually to announce a new hardware platform this year called Test Scale. This is for when your tests scale up to larger volumes. And this is, again, modular, but it's much smaller. I mean, the picture on the left, it's about 1 foot long or 30 centimeters. So each of those modules inside is about the size of a Post-it note. Now, this is exciting from an NI perspective because you still retain that customizable nature, but the smaller form factor allows you to potentially put it in the rack, but actually it's small enough you can fit it into the fixture, maybe mount it directly onto the interposer board beneath the DUT. This means you have a much shorter signal path. You can reduce your costs of wiring and your sources of error. It also means if you can get all of your instrumentation into the fixture, you actually don't need a rack at all, which saves you floor space and of course the cost of the rack itself. Now, right now, most of the applications we see, they kind of have a hybrid approach. They'll put some measurement instrumentation in the rack and some measurement instrumentation in the fixture. But NI's vision for these higher volume applications is definitely that we start seeing more measurements moving into the fixture for the benefits that I said around accuracy and cost. Of course, this still uses all of our NI software, as you would expect, and to plug into that. Now, we've been working with our experienced partners, and in fact, Averna contributed to the form factor of TestScale right from the initial concepts. It's important to us to be able to work with people who are actually building these systems every day to get their feedback on what these form factors would look like, because they have that sort of practical implementation of test experience. And so with this note, guys, I'll hand it back to you, talking about the systems you've built.
Great stuff, Graham. Thank you. And I'm glad you brought up TestScale. It's really a great low-cost solution that gets the job done. That's one of the reasons we've incorporated it into our Uniline design, simplifying standardization. As we were saying, hardware and software standardization will pay off quickly, whether it is a common core platform or not. And by having the same equipment throughout your business, that simply means you have more of it. In the event you need a spare while something is being repaired, with standardized equipment, chances are you already have it. If all systems are using the same PXI DAC card, for example, you can simply take one out and use it for another.
That's right. You know, and having things in reuse like spares on hand, there's never been a time that's been more important, right? I mean, right now, even common core power supplies are back ordered for 18 weeks. I've had customers who spend a lot more on much higher end power supplies that they didn't even need because the one they wanted was out of stock. Millions of dollars in product development and manufacturing have been delayed or lost due to these shortages around the globe. Many of the customers I have, you know, they're become so frustrated because they can't get their hands on the tools that they need. Having standardized equipment means having more than just spares. It means having access to equipment that may otherwise be impossible to get.
Oh yeah, definitely.
You know, earlier we talked on the topic I want to get into now. Companies often work in silos. Today, more than ever, it is important to create those synergies between departments and allow the entire organization to be more efficient and better prepared against issues linked to supply chain and obsolescence. Having all departments aligned on the same standard equipment makes these synergies so much easier to implement. It is important for a company to look at standardization as a unit and approach it together to make these incredibly important decisions. It's not an easy task. I know what I'm saying sounds crazy, right? Getting everybody to all your engineering teams to agree on the same thing is tough. But you know, several years back, it's actually what we chose to do. We took advantage of our annual engineering summit to do exactly that. This was just a few years before the pandemic. We had key players and decision makers from all locations across different departments, finance, R&D, engineering, you know, the time specifically blocked out for all of those teams to, you know, everybody to review all of the common equipment and select the best options to use moving forward. We discussed, you know, mechanically, what are we going to use for extrusion, you know, optics, any kind of like vision systems. You know, a system designed in Mexico will have the same e-stop and electronic components as a system would be designed in Montreal. And of course, more customizable for a customer that needs something specific.
It's very interesting, and it's something I actually consider often in my role here at Averna. Having standardized equipment allows to put in place strategies to be more reactive when it comes to quick delivery or technical support. By taking the time to do this, it's helped us in many ways. For example, from a procurement point of view, we have created parts lists with vendors, which allow us to ensure there will be stock on hand of designated equipment, covering future orders and spares. We can easily plan for projects ahead of time to meet required delivery dates. And quite frankly, this equipment ends up costing less because we can buy it in higher volume too. So having taken that time has already paid off for us. And I strongly recommend to anyone to take that time to do the same, by including everyone at the company, not just within the location or department.
Well said. You know, by standardizing test equipment throughout the company, everybody's speaking the same language, avoiding inefficiencies, but we also understand this isn't always the easiest thing to do.
Speaking of inefficiencies, we didn't really get into test automation, and really that's a subject anyone at Averna can address for hours, but We're here to focus on standardization, which doesn't necessarily mean automated test equipment. But for most applications, I will say that if you want to see a fast ROI, automation is a good first step. That said, there are definitely applications where fully automated solutions may be overkill, particularly in low volume, low complexity manufacturing. But regardless, standardization pays off quickly in any case. While a lot of companies are now working on fully independent, lights out style production, most businesses still require operator intervention to some degree. So it may be someone to actually handle the equipment, or it may be a person looking to access the data later. Either way, someone will be involved and they need to know what they're doing. So when dealing with standardized hardware and software, operators only need to be trained once. And once the user understands the system and knows how to access the data they need, they're good to go. So if you pick up the same equipment and use it for a different purpose, it will only take a small ramp up to move on to the next thing.
Absolutely. It reminds me of one of our customers that builds, custom switchgear components and breakers. These test routines can be very cumbersome, right? Mixed measurement approaches that assess the final build, they can be very different. The strategy employed on the delivered system that we did was relatively simple, though. We still covered a lot of their required test coverage, but in general, dielectric presence checks on components for each phase, neutral and ground, were developed. In this case, we developed an instrumentation platform that not only required it really only required different cabling and fixturing solutions for each subcomponent, and even one for the final assembled switchgear. The reuse was huge, right? The same instruments, user interface, cables, and vision cameras were used in each of the end-of-line testers, and this was deployed, in multiple different plants around the country, and even in different countries. This drastically reduced the operator ramped up, and even the ground-up cost of a new tester altogether. This allowed the customer to integrate this test strategy faster, cheaper, and without introducing clunky test variations. The test strategy between operators, engineering, and even R&D was seamlessly integrated. They were all speaking the same test language. The strategy, though, is not limited to just applications, right? Look at Averna. We have offices around the world, and I often work with colleagues that speak French, Dutch, Polish, Japanese, Spanish, and others. With exception, of course, to Raphael. Most of us don't speak all of those languages, but we do speak Averna launch.
Arigato, but my Japan is not so good yet.
Well, I struggle with English sometimes, Raph, but we move on, I suppose. My point is simply that there are times when communication can be difficult, but when we are all trained in the same hardware and the same software, we figure it out pretty quickly.
Of course, you're right, Alex, but I would just add that that's not limited to geography, right? The same translation is often required between departments, and standardization provides that.
Totally agree. All right, well, I think we're starting to run out of time here. I want to make sure we leave room for questions. Again, the goal of this webinar was to elaborate on where to standardize test in order to maximize your return on the test equipment investment. First, investigate the option of common core test equipment. This is the most efficient way to get the most out of your hardware. They pay off throughout the entire product lifecycle and save hundreds of thousands of dollars quickly. Even better, invest in off-the-shelf. Oh, I'm sorry. Yeah, I'm getting too ahead of myself there.
That's fine. Yeah, invest in off-the-shelf software and investigate if a common core platform for your application type already exists. So you can minimize NRE and you're already ahead.
Yeah, that's a great point. And really, even generic test stations may not be the right solution for every application. Even if your equipment will be standalone, make sure the same type of equipment and software is standardized throughout different projects, company, departments, and locations. This allows everyone to communicate easily, stay on the same page, and step in and out of projects quickly when needed. It even allows you to change out hardware if you run out, like spares we were talking about earlier.
Yeah, and don't forget, by having the same equipment on hand, you eliminate the risk of not being able to access the parts. Slowdowns, shutdowns can be avoided because whether you realize it or not, you're already prepared for this now. You already have that hardware. For complex systems and large test station pools, this definitely simplifies so much your personnel's training, maintenance, spares management, you just win overall on flexibility. Graham, was there anything you wanted to add on this?
I mean, I think if I was to add something, I would say don't underestimate how hard this can be to do well. In the Navy, they always say spend as much time planning the thing and you'll spend half as much time doing the thing. And that can absolutely be applied to standardization and building a test station. But if you don't want to spend twice as much time planning it, find someone who's done it before. A lot of these best practices for building standard platforms have been established, and they've been established through a variety of different industries that have really been forced into this standardization strategy. And so find either within your company or if you haven't that experience, an external group of experts such as the guys at Averna, and consult at a very minimum, consult on what your plan looks like and what that architecture should look like. And maybe you'll then take that further and build out some of the integration work or the infrastructure with them as well. But do spend the time planning. Don't underestimate how hard it can be. And talk to someone who you consider an expert in this space before you start. Because going it alone and doing this for the first time is not an easy prospect to do it well.
Yeah, we appreciate the perspective and always a vote of confidence, Graham. Thank you so much. So that's about it for us, honestly. And Graham, again, thanks for sticking around for questions. We'd love to hear from all of you. I saw some questions coming in. But if there is anything we haven't addressed or would like clarification on, please keep them coming in. Thank you, everybody, for attending, and I hope that you find this information helpful.
Thanks, Alex and Raphael, and of course, Graham. As you pointed out, we do have a couple of questions here. We are running out of time, so we'll get right into it. How do you decide which instruments should be standardized?
Good question. I mean, Raf, as a hardware team lead, I mean, what do you think?
Yeah, so it's not an easy task, and it takes quite some time, analysis, investigation to decide by where to start. Graham said it before. It is difficult. It's not an easy subject. But as an example, what we've done at Averna was really to concentrate on those most reusable equipment and most generic that they're not too specific. For example, a power supply. There's plenty of power supply manufacturer out there, but a lot of those products can be replaced by each other. So it's easy to standardize on 1, 2, 3 power supplies that will cover 90% of our test requirements. Another example could be IO cards, DAC cards. Same thing. There are commonalities between projects that make it simpler to say, okay, I will have on this project a DAC card that has a little bit more channels that I need, but at least it will be standard and it will be transferable from one project to another. So, and then there are the more specific equipment that are much more difficult to standardize on. But sometimes it is also feasible. So it does take some analysis and some studying before deciding on what to choose as a standard equipment.
Yeah, we use tools like that as well. So I think even in the previous webinar, take a look.
Yeah, that's right.
Great, thanks, guys. Do you have any recommendation for low volume, high mix production scenarios?
That's a great question. At least it's not high volume, high mix, right? So when we're talking low volume and high mix, it really depends on what measurements you're making and what you can automate that can help you decide what instruments you need to standardize in across the board. I mean, we also talk about end-of-line testing and DTS, that design test systems, or even DVT, right, which is development verification and device verification testing, which are a completely different subset of tests that you may want to perform. And that's typically what I think of when we talk about low volume, is that you're building 7 aerospace actuators, for instance, and you want to verify that each one are safe for flight, and that takes 24 hours, that takes 48 hours of steady cycling, for instance. In those cases, you need a power supply. You probably need a hydraulic unit. You know, you need standard components that you can kind of work with your inner departments to determine, well, if I need a DC power supply or I need an AC power supply and I need different voltage ranges, you can go out and find those things and you standardize on that, and you can potentially have multiple different uses. I mean, Graham, you have examples too, I'm sure.
Yeah, I was going to say, I mean, I think I would answer that question. If there's one area where the business case for standardization is maybe most straightforward, it is in that low volume, high mix setup. Because in order to be able to internally justify the investment cost to build quality, a really high quality test station, you need to amortize that cost across multiple product lines, because it's unlikely you can invest per product line a brand new tester, because you've got so many different products. And so in order to be able to increase the quality of your tester, and so increase the quality of your product, the calculation on standardization of tests, on standardized tests, becomes incredibly important to be able to justify that sort of total the money you're spending. And so actually I would say the higher your product mix at low volume, in some ways the easier it is to that calculation works out. And so it's the perfect opportunity. Of course, it's hard because your test coverages can be varied. And so that discussion that Raf was having around what should be in your core station and what should be specific becomes a really important one. But without knowing more about the individual application, it's hard to recommend that. But great point to bring up, whoever asked that question.
Graham, this one is specifically for you.
Yeah.
You've addressed standardizing equipment at the station level, but can you elaborate on expanding it on a larger scale?
Yeah, I mean, for me, as you move from a station to a test line to an entire organization, that's when the processes and the people side of standardization become more and more important, because you've got more stakeholders. It's also, I think, from a technology side, the scope of the technology included in your standardization initiative grows. An example of this would be database communication or systems and data management. It's likely that across your factory, you only really want one set of systems management software to be able to connect all of your test stations to your data lake or to your MES. And often the work of doing that falls upon test engineers. But in my expectation, test engineers, they don't add their most value when they're doing IT-related data tasks. They add their most value when they're doing test engineering, which is involved with the dart and the signal path. And so I think expanding your project or your standardization initiative to incorporate anything which you see is common across your factory, but is a low return activity for a test engineer, is an opportunity for standardization and for commercial off-the-shelf tools. And I would suggest that data standardization and data infrastructure, IT infrastructure standardization is a top of mind for a lot of people today.
I see a question in there as well. I like that one. Have you standardized using a HAL? For example, could you use a different approved power supplies? You know, I feel like it's every single day when I'm in the office, the software engineers are talking about a HAL-MAL, right? A hardware abstraction layer and then a measurement abstraction layer. And really, it comes down to your software architecture. You know, this is one of the hardest things to get our customers to agree on is how do you build an architecture that is scalable to multiple different sites, even with legacy equipment, you know, bringing it on. It is an incredibly challenging activity that we have been successful with. We use, you know, we use NI LabVIEW test stand, and in our case, Averna Launch is a GUI that is a wrapper for test stand, and it allows us to build from a process model that is standardized. So we can use a HAL in some cases, either in a monolithic lab view or in test stand. And you could even build these, of course, in Python or C or whatever your test platform is. But yes, that is one of the keys, like we were saying earlier in the presentation, to standardizing test is agreeing on your architectures, which is often the most challenging part of a project.
I'll add to that, Alex. So we were speaking publicly with Philips a little while ago, the test director from the ultrasound group. Now they employed a HAL, actually a very sophisticated HAL, and they justified the investment to put into that HAL, not just on the time savings on the NRE, but by implementing that HAL in a highly regulated environment such as medical. They were able to knock 6 months, I think it was 5 to 6 months off their certification, FDA certification time, because there was so much standardization and so many code modules and hardware that had already been through that process that they didn't have to change when an NPI came along. And so if you are looking at HALs and MALs and you're working in a government regulated environment, that's an important calculation you should build into your plan.
Absolutely, and the thing I would add to that is, it's easy for a power supply because generally they do the same things, right? Over OCP, OVP, but when we're talking about specific instruments, maybe that are more unique to a specific subset of tests, you don't have a lot of options out there. And so creating a HAL that is scalable for those very unique instruments is borderline impossible in some cases. And so it is important to, I would say, to reduce the idea of IO power supplies. You can reduce a subset of your instrumentation, and obviously PXI has great options for that as well. Amy, anything else for coming in?
Absolutely, just wanted to give you the chance to take it. How do challenges with fiber optic testing tie into test standardization of high cycle life interconnect?
That's a great question. I know we work with a couple of fiber optic manufacturers, but I don't have very personal experience with it. Maybe Raphael, do you have any experience with fiber optic testing?
No, not directly. So,
or if someone could provide some clarification, maybe whoever asked that, what is meant by the question.
If we can't get that answer right away, we can certainly reach out to them after this webinar. I'll move on to the next question in the meantime.
Sure.
All right, sorry there. How can you help a customer who buys an Averna PLTS test tool to expedite the calibration process?
That's a good question. I mean, this is something that we run into actually quite a bit. In fact, we've had a couple of customers in the past that have had a challenge behind this. So PLTS, physical layer test system, in this case for a modem, right now, I think the challenge is behind lead time availability. And so when we order different materials, each of these cards, especially as Graham was saying earlier, they're validation graded instruments and they need to be calibrated. And they usually come from a manufacturer calibrated. But in some cases, that calibration expires after 12 months. And when things are delivered, at different intervals, it's challenging to deliver a full system that is calibrated together. So one thing that we recommend is having a very specific calibration routine scheduled within your plant. And so in most cases, a customer will have standards of their own for what level of calibration they need and how often. And so whenever that happens, Averna can certainly connect you to calibration houses, or even bring it back to the original manufacturer for calibration. And we can get the schedule of all of those instruments together, which is the challenge here.
Great, thank you. We will make this one our last question. Do you have an example where not standardizing equipment was a problem?
I mean, lead time comes up all the time, right? We haven't standardized on something, we don't have something available, and it takes us 18 weeks, 20 weeks to get something else. Graham, you've seen this a ton. What would be your input?
I would say yes, that there's a lot of challenges we've talked about, NRE and engineering reuse. I think one that maybe to take a slightly different direction that we haven't talked about is the people side of not standardizing. We live in a world which is different to what it was 20 years ago, in the form of when engineers come onto our team, they don't have an expectation of staying there then for another 15 to 20 years, or however long the test station is looking to be maintained for or sustained for. And so I'm sure you've all been in situations where you've come into a new group and you're presented with a test station and a pile of code, and you just have to sit for a week and try and work out what the hell is going on. That situation is becoming more common as the younger generation of engineers coming out of university now have an expectation maybe of joining a test group for a couple of years before moving on to a different one. And so the more that we can standardize our processes, our onboarding, and our code infrastructure, allowing people to ramp up quickly on how to build, maintain our test stations, the more success we can have. And I could give numerous examples of where lack of standardization has created significant inefficiencies on a team when they suffer with attrition or lack of resources. I won't name the companies, don't want to call them out, but absolutely, I would say that is it's a pain on everyone's minds right now, is the people side of standardization.
Great. Well, thank you so much to all three of you, and thank you to everyone in attendance. And we hope that you enjoy the rest of your day.
Thank you so much, everyone.
Thank you.